All right, so this is a very important idea in stats. We talked about a normal distribution. That just means it's something that's a bell curve. Problem with a normal distribution, though, is it's different for every case. Like we were just talking about average test scores on this test, and it seemed like the average was 675. But obviously, you could have another test like the SAT, and maybe the average on the SAT is like 1100 or something. So these numbers are always going to be different. Is there some way that we could make it consistent so that every normal curve will kind of look similar? And the answer is yes, you can make what is called a standard normal distribution. Standard normal, all that it means is that all of these values down here get changed into z-scores. And you might remember, you may not remember, but you might remember from section 2.5 that this right here is the formula for the z-score. So I'll give you a very simple example. Let's do average height. Suppose that was supposed to be a straight line, sorry about that. Suppose the average height for American men is 70 inches and it has a standard deviation of, let's say, 5 inches. So I'm showing you a couple standard deviations either way. Alright, so we could write it like this. This is just a normal distribution. We could also change each of these to z-scores. Okay, so the formula for z-score is this. Okay, and you can see it right above. So if I want to convert a score of 70, I could say, well, the value I'm interested in is 70, minus mu, the average height is 70, and then the deviation, that's supposed to be a sigma right there, the deviation is 5. 70 minus 70 over 5 equals 0. So this normal distribution right here is now going to be changed into a standard normal distribution, and that score in the middle, 0, that represents the average. That represents a z-score of 0. 75, you could plug it into this same formula right here. 75 would become a z-score of 1. 65 would become a z-score of -1. All I'm doing is plugging those numbers in for x right here and putting them out as z-scores. Okay, and when you have a bell curve that is not based on like average heights or average test scores, but when it's instead based on z-scores, the name for that is called a standard normal distribution. Okay, so that's the idea. So let's actually practice working with some of those things right now. Most of this is going to be done on the calculator. Okay, here's a better picture than I was drawing of a standard normal curve. Z-score in the middle. Okay, these are all z-scores. So right, if you're average, your z-score is 0. You're not above or below average. If you're above average, you have positive z-scores. Below average, you have negative z-scores. And the total area under this curve, remember area means probability, so the probability that you have a z-score somewhere under this curve is 100%. It doesn't matter where you are, you're guaranteed to be somewhere on the bell curve. Alright, this is just some more notes on z-scores. Okay, so there's a way to do this using tables in the back of the book, Table 4, Appendix B, and I'm going to show you almost exclusively how to do it with a calculator. I don't really think it's efficient to use the table. If for some reason you don't have the calculator that does this stuff, you could use the table. It's pretty clear how to use it if you read on page 238 in the book. They explain how to do this, but it is a lot easier to use the calculator. Okay, so I'm going to show you that. Here's a couple things to know about the standard normal distribution. Let's just take a look at these. So actually, I'll go back to that picture that they have, which is a little bit better. So the cumulative area, remember area means probability. Probability is close to 0 for z-scores that are close to negative 3.49. Okay, so what does that mean? I mean, negative 3.9 is like over here. You can see there's very little probability of having a z-score that low. Okay, on the other hand, over here, you've covered like almost the entire area. So there's almost 100% chance that you've covered everybody by the time you get way over to the right of the curve. Okay, the cumulative area for z equals 0. Remember, z equals 0 is average. It's right in the middle. This area right here is half of the area, and that's why it says 0.5, because the whole area is 100%. Half of 100% is 50%, or 0.5. Alright, so how do you actually solve this? Here's what the table looks like. I know it looks imposing, but like I said, if you're interested in knowing how to do it with the table, read page 238 in the book, because it explains it pretty well. I'm going to show you how to do it on the calculator, though. Okay, so it says find the cumulative area that corresponds to a z-score of 1.15. And by the way, this link right here gives you all the instructions for how to do it on the calculator. I'm going to tell you how to do it, but in case you forget or in case you just want a hard copy resource, that's where you can find it. So what I like to do for these problems is just sketch a graph. So here's a z-score of 0. We want 1.15. So it's going to be somewhere on the right of the graph. And when they're asking us for cumulative area, they're asking us for the following. They're asking us for what is all of this area. So the first question I have for you is that area going to be more or less than 50%? Is it going to be more or less than 0.5? And hopefully you could tell me, well, we've gone past 0, so we're definitely supposed to get an answer of more than 0.5. So that's how you can check to see that your answer is reasonable. Okay, so let's do this on the calculator. Here's what you need to do. Okay, you go to second vars. This works for TI-83 and TI-84. Go to second vars, select not normal PDF, that's not what we want normal CDF. Okay, it's very important that you pick CDF. If you don't, if you do the other one, it will be wrong. What does C stand for? C stands for the word cumulative. It means cumulative area. It means like how much area have you accumulated or added up by the time you reach this Z-score right here. So you want normal CDF, and on the TI-83 it's just going to bring you back to the main page. On the TI-84 it's probably going to bring you to a screen and ask you for things like lower and upper. Okay, so I'll do it both ways. So if you have the TI-83, this number right here is going to be lower, then you put a comma, the next number will be upper. Okay, then you put a comma, the next number should be mu, and the next number should be sigma. So you put a bunch of commas. Okay, and that will, if you have this page, it will probably just tell you directly. So the lower boundary, what's the lower boundary? Lower boundary is what is the z-score over here? Okay, like if you kept going, and really it's negative infinity. This thing goes forever to the negative, but you can't put infinity in your calculator. So what you should do is put a very, very large negative number. I'm going to put negative 10,000. Okay, negative 10,000. There's such a small chance of somebody having a z-score that low that kind of stands in for negative infinity. Okay, the upper boundary is this boundary right here. It's like the right boundary. Where is this area being bounded by? Well, on the other side it's going to negative infinity, but it stops on the right side. It stops on the upper boundary at 1.15. So that's my upper. Okay, and obviously if you're doing it this way, just be plugging those numbers in on the TI. This is the 84, and this right here is a TI-83. Okay, what is mu right here? Well, what is mu in the middle of the table? It's always 0. So if you're doing a standard normal curve, the mu will always be 0. And what is sigma? Well, how much are we going up by each time? Remember on the other page we were going by ones, going by like counting up by 1. So the standard deviation, how many standard deviations are we going? We're always going 1. Okay, so if you put that information in the calculator, if you put normal CDF negative 10,000, comma 1.15, comma 0, comma 1, and then you should close the parentheses and press enter, you will get the following answer. You'll get 87.8749, which means 87.49% of the area is shaded in right here. Okay, and that kind of looks right. We said it was definitely going to be more than 50, and it's actually quite a bit more than 50. It's 87%. Alright, so see if you can pause the video right now and try the same thing for negative 0.24. Okay, so I will clear this off just so we have a clear picture. So negative 0.24 is going to look, I'm going to sketch another picture, it's going to look like this. Here's 0. We're at a negative z-score, so that means we'll be maybe right over here. First question I have for you, we want cumulative area, which means up to negative 0.24. Is this area, is that going to be greater or less than 50%? And hopefully you would be able to say, oh, this is the 50% mark and we haven't reached that yet, so this should be less than 0.5 if we do this correctly. Go back to normal CDF just like you did before. Okay, and again, this is lower, this is upper, this is, I'm going to put up for upper, this is mu, this is sigma. The mu and the sigma are always 0 and 1 because it's always 0 in the middle. That represents mu, the average, and the deviations that you're traveling are always by ones. Okay, the lower boundary is another way of saying lower is left. What's the boundary over here? It's going to negative infinity, so we'll use negative 10,000. And what's the upper boundary? This is where it stops. That's the upper boundary, so negative 0.24. And when you calculate that, which I am doing off screen right now, when you calculate that, you should end up getting, I'm getting 0.4051. Or actually, I guess if you round that, it would be 0.4052. Which means 40.52% of the area. Does that make sense? It does, because we said we're supposed to get less than 50, and that looks like it's about 40% of the graph. Okay, so that's how you find area using the calculator. I think that's a lot easier than using the table. If you did do the table, they're showing you a picture in the book here of how you would do it. You'd find a z-score of 1.15, and you can see that's the number we got right there. Okay, and then this is for negative 0.24. This is just a summary of how to do it in the calculator, and you can see there's the lower, there's the upper, there's mu, there's sigma, and that's the number that we got right here. Okay, and the next one I'm going to show you, if you are using the table, they say, you know, if you're midway between two z-scores, just use the area. So if I was between like 1.2 and 1.3, you'd use like 1.25 or something like that. Let's say this had an area of 10, this had an area of 12. What's halfway between 10 and 12? You'd use 11. That's only if you're using the table, though. All right, in the next one, we're going to do some more examples along this line.